Hello? Can you hear me?
Yes.
Perfect. See. 9 o'clock. I guess we'll do something. We're almost done with this class. Like I said.
Hello.
Hello, can you hear it?
Yes, I hear you.
Perfect. Today should be a quick one. It shouldn't be that long. We're just going to do section 8.4 and be done with it. Then we'll have just chapter 9 next week. That's bad. Other than the graphing at the end might be a little issue, but I'll show you how to do that. Anyway, let's just do this and get it over with, and then go take a walk. It's a beautiful day.
Oh, yeah.
Yeah. Okay, radical equations. Radical equations basically mean equations that have square roots in them. Okay? I don't know where they dug up the word radical, but that's the square root symbol right there. I'm going to write that in there. Come on, baby. You can do it. Square root of x equals 3. Okay, that's what we're going to solve. And just like any other equation, the way you solve equations is that you see an operation and you want to isolate that operation, and you want to get, like, if you see a plus, you instinctively want to do the opposite, minus. So plus, the opposite of plus is a minus. The opposite of multiply is divide. I mean, that's what you did in Algebra 1. Now we got to figure out, here we have a square root. That's an operation. There's always an opposite operation that cancels out the square root. So what do you think the opposite operation of a square root is?
The square?
Square. You're going to square both sides. See? I'm going to take that side there, square it, and then whatever you do on the one side, you do on the other. And so what happens is the square and the square root cancel out, like we saw before. We get x equals 9, and there's your answer for that problem. Not too exciting. That's the answer for that. I'm not even going to waste time then doing that. Okay. Now, when you start doing these problems, let's say square root of x plus 9 equals 5. Now, just because you see a square root doesn't mean you square both sides right away. Let me get some water. Because if you square both sides, you can do it. I mean, there's nothing that says you can't do it, but it's not going to buy you anything. So we learned the other day that when you see something like this, you have to take what's inside the bundle and put it in and square it, multiply by itself, right? That's what that square does. And so then you're going to see this and plus 9. And I'll even go so far to say that's 25 on this side. Okay. Now, what are you going to do this? You're going to FOIL that, right?
Mm-hmm.
Now, if you FOIL it, aren't you still going to get a square root in your answer? I mean, it's not important to know, you could FOIL that. I trust you can FOIL that. And I bet you when you do the inner and the outer, you're still going to get a square root. So squaring both sides didn't buy you anything. It just made you do more work. Okay, so let's erase this. Don't do this right away. Let's push this up. What you're going to do is instead rewrite the problem and say plus 9 equals 5. Rewrite the problem. Let's make a better looking 9, okay. Before you square both sides, you want to isolate the square root. In other words, what that means is you want to make sure there's a square root by itself on one side of the equation. There can't be a plus 9 associated with it. So you usually square both sides as a last operation. What you want to do is get rid of the 9 from both sides. You'll get the square root of x equals, what's that, -9, -4?
-4.
And then now you could square both sides and you're not going to have a problem. And then this will be x equals -4 times -4 is 16 as your answer. Now, you're going to have to get used to what I'm going to tell you here. Everything we did is fine. Everything we did is correct. Just because you do something correct doesn't mean you're going to win. You need to take problems with square roots are notorious for giving you answers that just don't work. It's just the nature of mathematics. There's your answer that we calculated. You need to take that 16, put it in the original problem to see if it really, really works. And does it work if I plug in 16? Square root of 16 is 4. 4 plus 9 is 13. 13 is not 5. It's not 5. So that, we did the right thing, but that didn't buy us anything. There's no solution.
Oh, okay.
There's just no solution to this problem. Okay, check your answer. That's right, I'm not lying to you. Now let's see if the next one gives you a better answer. Let's start with a nice fresh canvas here. File, new, okay. Let me erase this guy. Don't save, okay. Let's put it over here. So let's see, square root of x minus 9 equals 5. So what's the first thing you would do?
Minus 9 on the other side.
Yeah, add 9 to both sides.
Mm-hmm.
Add 9 to both sides.
Okay, add. So we do the reverse.
Yeah, you always do the reverse. I mean, if this was x minus 9, forget the square root. I mean, if you just saw x minus 9, you add 9 to isolate the x. You always do the opposite operation.
Yeah.
So, but this time what we have here is the square root of x. That cancels, and that's plus 9, so that's 14. That's 9 plus 5, 14, okay. I guess we'll square. Now it's okay to square both sides. It's okay to do that. So that gives me x. 14 times 14, what the heck is that? What, 296? I don't know. I don't know anymore. Let me just get a calculator. I don't trust myself anymore. Where's my calculator? Right here. Calculator. 14 times 14 equals
196.
196. 196. Before you put 196, though, that's a candidate for being an answer. 196, you always have to check to see if it comes out right. So I believe it'll come out right, because if I stick in 196 underneath the square root of 196 is 14. 14 minus 9 is 5. Yay, that's a good answer. Okay? So you always have to check your answer when you do these problems. Okay, we can do that one. Big square root. Big square root of y plus 11 equals 3. I look at this problem, and you know what? Even though we got a big mess underneath that square root, that's just one big bundle here. I do have a square root all by itself on one side of the equation. I do have that. So square both sides. That's where you would square both sides. That's perfectly okay, because when you cancel, the square and the square root cancel, leaves me with it liberates the y plus 11. And that gives me 3 times 3 is 9. And if I subtract 11, right, that's what you're going to do. You're going to subtract 11 to solve for the y. You get y equals -2. Ooh, okay, -2. Now, what's the next thing you're going to do?
-2 minus 11 or plus 11.
11. In other words, you're going to plug in that -2 in the original problem and then do the math. And then if you do the math, do both sides equal one another? And I think you're right. -2 plus 11 is 9. That 9 is underneath the square root. The square root of 9 is 3. Yeah, 3 equals 3. So it works. It does work. So we got 2 problems that work. Fantastic. See, are we having fun? Isn't this great?
Mm-hmm.
What else you can do? You're going to do on a day when you're in lockdown? You might as well do some math. You can't go outside. Yeah, you can go outside if you take a walk, but you can't have fun anymore. Fun's over. We got to do math. Let's see. Number 5. Ooh. Close this. There's nothing ooh about this problem, by the way. File, new. Okay. The only thing that looks strange about this thing is you got 2 square roots, and that's all right. So you have 2 square roots. Nothing changes in the way we do this. 2 square roots. All we're looking for is a square root by itself on one side, so we can get rid of the square root. In this case, both sides have isolated square roots. So I want to get rid of this square root right over here because it looks bad. I'm going to square that. But whatever you do on one side, you're going to do on the other. All right? And so guess what? Both square roots go away. X equals 2x minus 3. See? Both square roots. It looks scarier than it is. All you're looking for is a square root by itself on one side of the equation. And if you see that and you want to get rid of that square root, you square both sides. If the other side is also a square root, fine. You get rid of that too. So what I'm going to do now is subtract 2x. All right, that's an x. And then say x minus 2x is negative x equals negative 3. And that negative x means negative 1x. So x is being multiplied by negative 1. So I'm going to divide both sides by negative 1. Cancel. See the opposite. X equals 3. Oh, now before we say 3, because you'll always see this, there is no solution in these problems. Let's take the original problem, plug in a 3. So what if I plug in a 3 in the original problem, I get 3 on that side. Square root 2 times 3. 2 times 3 minus 3. Okay. So this is the square root of 6 minus 3, which is the square root. 6 minus 3 is 3. And so, yeah, both sides work out. Okay, both sides do work out. So I'm going to be confident that when I punch in a 3 in here, 3, check your answer. Great job. We're having fun. Getting things, we're getting sick of getting things right. Okay, we need more challenge. More of a challenge. Maybe the next one's more of a challenge. And let me see what the next one is. Okay. Got 3 of those problems. Okay. All right, we'll do. I might need more space. I might need some more space. So let's get rid of this. Get rid of that. Don't save it. Okay, file new. New. Come over here. Okay. All right. Square root 2x plus 6 equals square root 5x minus 9. Minus 9. What are you going to do? I think I see a square root by itself on one side. It doesn't matter if it's on the left or the right. I'll just pick this guy. I want to get rid of that square root for sure, because if I square that, that'll get rid of this. You'd also, if whatever you do on one side, you got to do on the other. That's the balancing of equations. You get rid of this, you get rid of this. Basically, you have no more square roots in the problem. God, I'm getting late. I'm getting edit undo. Edit undo. Edit undo. Okay. 2x plus 6 equals 5x minus 9. All right. I'm going to solve this equation. I'm going to subtract 2x from both sides. 6. Subtracting 2x. 5 minus 2x would be 3x. Plus 9. Edit, undo. Edit, undo. That's the nice thing about this. Edit, undo. Edit, undo. Edit, undo. Oh, yeah, minus 9. I didn't do anything with the minus 9. So bring that down. I put down plus, which was wrong. Okay. What I'm going to do now is get rid of the minus 9. The opposite of minus is plus, plus 9. So if I do plus 9 on both sides, I get 15 equals 3x. And now x is being multiplied by 3. The opposite is divided by 3. And so what I get is x equals 5. As a candidate, not necessarily the answer. It's possible that it could be right. So let's see. What do? You take that 5 and you plug it in. The original problem. Let's see. Let's just concentrate on one side. 5. 2 times 5 is 10 plus 6 is 16. Square root of 16. Remember that. Square root of 16. Here's how we remember it. We write it down. Is equal to, okay, 5. 5 times 5 is 25. Minus 9 is 16. Square root of 16. Both sides work out. Both sides work out, so I'm very confident that that's going to be my answer. 5. Hit enter. Yay, 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 yay. I don't know why they gave us 3 of these things. Will you let me do this? This is speed up number 7. Now let me just clear this out. Don't save. File, new, okay. I mean, we just did 2 of these problems. We had square roots on both sides. When you square both sides, I mean, why don't you just say 2y plus 6 is equal to 2y minus 8. Agreed? If you square both sides, you're going to get rid of the square roots. So why waste the effort writing that down? Let's see. Subtract 2y from both sides. Get rid of the variables. Uh-oh. I see why this problem is here. All right. I subtract 2y. 6 equals. Well, geez, I lost my variable. 2y minus 2y. There's no more y's. Equals minus 8. I can't. I lost my y. If you lose your variable doing the right thing, well, you lost it. There is no solution. In fact, 6 equals minus 8 is a sillyhood. It's false. You can never make something false true. So there is no solution to this problem. Nothing. Check your answer. Fantastic. So we just did half the problems in 18 minutes. 18 minutes. Okay. Okay. Let's see. Let's see. Write this down. I'm going to quiz you right now. I'm going to throw a quiz at you. Plus 3 equals 5. What's the first thing you're going to do?
Subtract 3.
What was that? Say it again. I'm sorry.
Subtract 3.
Subtract 3. Very good. You got it right, because you can't, in order to do anything with this square root, which you ultimately want to get rid of, you have to isolate it. There can't be any operations near it. So subtract 3 from both sides. Very good. X plus 9. Underneath that 1 square root equals 2. Squaring both sides cancels. X plus 9 equals 2 squared is 4. And it looks like x is equal to minus 5. That's a candidate. I don't know if it's right, though. I think it's right, though. Plug it in. Minus 5 in the original problem. Minus 5 plus 9 is 4. Square root of 4 is 2. 2 plus 3 is 5. Yay. Yay. Try to throw some excitement into these problems. They're not that exciting anymore. Not that exciting. Yay. Maybe the next one's exciting. This one's exciting. This one's exciting. Okay. So much so, I'm going to start off with a new. Let's see who's here, by the way. Very good. Very, very good. Very nice. Clear it. Oh, I've been posting these videos, by the way, on my website. Okay, just go to my. If you need to look at these videos, I'm recording them as we speak. Technology is fantastic when it works.
Okay.
And if you go to my website, just go to my main page, cs.stick.edu. You'll find a link to my YouTube, and then you could find them there. You can find them there.
That's awesome.
I tell you Algebra 2, and I tell you the topic, and then you can search for that. You'll be fine. You'll be able to look at it. It's mixed in with a bunch of Java videos, so just ignore the Java videos. Okay, source. Get rid of this. Get rid of this. Why am I excited about looking at this problem? File new. File new. Okay. Move this over here. Okay, here's what I'm going to do. Write the problem out. All right. First things first. What's the first thing you will do to this problem?
Add X.
There he's a master. See, when I retire, John's going to take over right there. Okay. X plus 13 equals X plus 1. Okay. Now here's what makes this exciting. I got a square root that I can get rid of. It's all by itself on one side. I can get rid of it nicely by squaring. But now I got to square this guy. Okay, got to square the whole side, everything. This cancels, leaves me with an X plus 13. But what makes this exciting is before we just had numbers here, right? We just had like 6 and we square 6 or something. Here we got to square this bundle. You got to do this. Okay, you got to square the bundle, and that complicates things because, you know, what are you going to do when you see 2 terms times 2 terms? You're going to FOIL it, right?
Mm-hmm.
So you're going to say first, outer, inner, last. X squared. Let me just do the FOIL. X squared plus another X is 2X times the last term is, that's a 2X. 1 times 1 is 1, and that's the FOIL job of this. But let's bring down the rest of this stuff. Okay. Let's get rid of this. So what do you do now? You did this in chapter 6. Whenever you have a problem with a square, you got to have an equal 0. So that means, let's get rid of minus. The opposite of X is minus X. The opposite of 13 is minus 13. Whatever you do on one side, you do on the other. Let's line these up. Minus 13 gives me a 0 equals X squared. 2X minus X is X minus 12. Okay, so there's a lot more work to this problem than we just saw. Okay, what do you do now? You're going to factor this. Just brings back some nice memories, right? X. See a minus 12 plus and minus 4 and 3 equals 0. So you got your factors equal to 0. You set your factors equal to 0. You go ahead and you say X plus 4 equals 0. Let's separate these things like this with the wall. And this is X minus 3 equals 0. Solving those little equations, I get 2 answers. Minus 4, X equals 3. These are possible answers. Okay, what we need to do is we got to check them. We got to check them, see if they work out. Let's try the positive one for not that the -4 can also be an answer. Don't just because it's negative doesn't mean it's a bad thing. But I'm going to try the 3 first because I can tell by looking at this 3 will work because 3 plus 13 is 16. They like that 16. The square root of 16 is 4. 4 minus 3 is 1. So for sure, 3 checks out. Let's try -4. Now, -4 might be a little bit of a problem here. Let me see if I can try to make it a little bit wider here. See, what I want to do is stick in -4. So I get the square root of -4 plus 13 minus a -4. That means when I plug it in, it's a minus a -4 like that. Minus a minus equals 1. And -4 plus 13 is what? 9? Square root of 9 is 3. Double negatives are positive. And I'm going to stop wasting the pixels because 3 plus 4 is 7, not 1. So no good on this. This is no good. NG. The only answer that's right is the 3. That's the only answer. You got to check your answers. And it's not because the answer is negative, because it is possible to have a negative answer. That's okay. We've seen that before in other problems. We had a negative answer there. So that's so just you got to check your answers. That you can't get away from that. Okay. So there's not much more. We got maybe 5 more problems, and then you could enjoy the sunshine. Now the problem toward the end, there's a word problem that's a pain in the neck. I'm going to prepare you. The very last problem in this set is a pain in the neck. It only happens once. If you don't understand it, that's okay. You'll still do okay. Just get the rest of this stuff done. Anyway, okay. I need some space here. Need some space. Get rid of this. Get rid of this. Don't save it. Don't save it. File, new. Okay. Come over here. Let's move this out of there. Move this out of here. Okay. All right. X equals 1 plus 4 square root x minus 4. Oh, that's real ugly, man. That's real ugly. But bear with that. Oh, I feel bad for you guys too, by the way. I listen to some of these videos. My voice is irritating. Jeez.
No, it's not.
Horrible. I can't even listen to myself. It's disgusting. Anyway, I feel bad for you. It puts you
exaggerate.
It puts you to sleep. Yeah, I'm good. If you can't sleep, just put one of my videos on in the background. And then you'll go to sleep. Anyway, let's see. First thing I would do, you got to get this square root isolated, right? Okay, -1 on both sides. I think you're convinced of doing that. But now I'm going to throw a little bit of a monkey wrench into this because the next thing that you might want to do is, I said, isolate the square root. Yeah, isolate the square root. See, if the square root has a 4 being multiplied. If you really and truly listen to everything I say, I got to get rid of this 4 right over here, and I would get rid of it by dividing both sides by 4. The problem and it's true, it would work. The problem is on this side, you'll have a division by 4, and you have a fraction. And if I square both sides, I'm going to have to square a fraction, which in itself is okay, but you don't need to go this route. You could have a number in front of the square root that's multiplied. It's okay. You can do that. It's just that we never saw a problem like this before. Just square both sides, even the number. Just square both sides, even the number, because that's not going to be a problem. Okay, square both sides. So if I could put the equals over here, I need a little space. See, when you got 2 things that are multiplied. A times B squared means you square the A. See, there's no FOIL here. There's no plus. You just square the A and you square the B. So I'm going to square the 4 to give you 16. multiplied. What you're multiplying by is the square root and the square that cancel, leaving you with the x minus 4. You're left with this thing. So you did get rid of the square root, and we avoided the possible fraction when you if you were to divide by 4. So that's all right. You can just do that. This is a FOIL job. Okay, that's what that means. That's a FOIL job that has to be done. And if I do this, x squared, and I'm doing out the FOIL. Minus x outer minus x inner is minus 2x total. Combine the like terms, and -1 plus -1 is 1. It's equal to, multiply through, 16x minus 64. Okay. All right. You could do this. You did this chapter 6. You got a problem with the square. Minus 16x plus 64 minus 16x. That's a plus, right? That's a plus. Plus 64. This gives me the equals 0. Now this gives me x squared minus 18x plus 65. Okay, so they're not going to give you a problem that you can't do, so I bet you we can factor it. I need two numbers that multiply together to give you 65 and add up to be 18. I'm going to start off by saying x and x, double negatives for the positive. 15 and 3, 13 and 5, 13 and 5, 13 times 5. 13 times 5, I think, will work. Okay, that gives me 65, and they would add to be negative 18 in the middle. Okay. Agreed?
Yes.
Good. And so this equals 0, and this factor equals 0 gives me 13 as an answer, and this one gives me 5 as an answer. Possible answers. So do these things work? Let me try the 5 first. 5, remember, 5 equals 1 plus 4 times 5 minus 4 underneath the square root is 1. Square root of 1 is 1. 1 times 4 is 4 plus 1 is 5. That 5 works. That checks out. That does work. Now let me try the 13. Let me put it up here. 13. 13. Just plug it in 13. I get 13 equals 1 plus 4. And I think this will work. I don't know. Well, I'm not sure. It's 13 minus 4. Yeah, this is going to work. 13 minus 4. This is going to work. Because this gives me the square root of 9. Square root of 9 is 3. 3 times 4 is 12. 12 plus 1 is 13. Both of them work. And it's not because they're positive. A lot of people say, oh, they're positive, and because they're positive, it works. It doesn't work that way. Negative numbers would work. Okay? But
so we plug the two numbers?
We plug in the two numbers. We plugged in the 13. That checked out. I plugged in the 5, and the 5 gives me the right answer too.
And what do we do then? Do we plug the 2?
Nope, you plug in 13, comma 5.
Okay, that's what I wanted to know here.
Yeah, you plug in the answer. Use a comma to separate the right answers, and I'm going to say that's right.
Okay.
There you go. All right, 4 more. 4 more done. I think, do we have word problems? Let me see word problems. No word problems. No word problems. Okay, let's get rid of this. Don't save. Say file, new. Okay. Come on, go away. It's not going away. Okay, good. All right. Square root 81 minus 10x. It's an ugly 10. Bear with it. You see it over here, x minus 9. Okay, I got a square root all by itself. I'm going to square both sides. Gets rid of this. I'll probably try to make it look prettier now. Minus 10x equals square both sides, square both sides. Now, this is a FOIL job. My mouse is moving around here. Hold on. I clean the gunk on the bottom of it. Okay. Equals. Okay. X squared. This is minus 18x, outer and inner, added together, plus 81. That's what that is. I'll put the 81 over here, minus 10x. I'm just bringing that down. Okay, subtract 81. I got to have it equal 0, plus 10x. Subtract the 81, plus 10x. Equals 0. Great. X squared. This is negative 18 plus 10, negative 8. X. And the 81s go away. Okay. So I believe we did everything right. You don't have to have a number there. We still have to factor this, and that's not that hard. Just pull out an X, so you factored it. See, we haven't seen too many problems like that. This is good. Okay, you can do we always did the hard stuff with magic numbers and all that kind of stuff. Okay, if there's no number, you can just pull out an X, and that's a factor times this. That's a minus 8. So when you set the factors equal to 0, X equals 0 is one answer. Okay, X minus 8 is the way you calculate the next answer. X equals 8. So you got two possible values. Let's see if they work out. 0. 0. Square root of 81 minus. Let's do this out. Let's do this out. See if I can pull it out. Yeah, I can do it over here. So we have to take this square root 81 minus 10 times 0. That's a 0. Equals 0 minus 9. Square root of 81. Right? Because 10 times 0 is 0. Equals negative 9. The square root always gives you a positive answer. Okay? The square root always gives you the positive answer, never the negative answer. Is equal to negative 9. Nope. No good. X equals 0 can't be right. Doesn't work. X equals 0 does not work. No good. NG. Okay, let's try the 8. 8. Square root 81 minus 10 times 8 equals 8 minus 9. This is 80. 80, you got to do multiplications first. 80. 81 times minus 80 is the square root of 1. Equals 8 minus 9 is negative 1. And nope, that doesn't work either, because the square root always gives you a positive answer. Nope, no good. So we did all this work for nothing. No, all this work is for nothing. Well, get used to it. That's what life is all about. You do a lot of work and you do everything right and you still have problems. Check your answer. Hey, three more, then you're going to be done with this. What's so good about this? What do you think? What do you think about that problem?
It's okay.
Okay.
Yeah.
Okay.
We're gonna work.
Intense.
Intense?
They're intense.
Intense? Well, you haven't seen intense yet.
Great.
The last problem. But the last problem is just a pain in the neck. You'll know, you won't see it again. It's only seen in the homework. But okay. Don't save. Just be it looks like a lot of work. Just have faith that, you know, you're doing an operation, and just have faith that these operations are being done correctly. I mean, you see a square root, you square both sides. You just, if you see a FOIL, you got to FOIL it. That's all. Don't save. Don't save. All right, let's try this guy. File new. It looks like a lot of words. But if I go through these words, come on. Oh, come on. If you go through those words, okay, there's a pyramid. And it basically says that the formula that relates all these variables, I mean, the height of the pyramid and the base of the pyramid and the volume of the pyramid, it's an actual formula, says that they're related like this. Okay, just accept it. Accept it as being fact. Just, there's the base is equal to the square root of 3 times the volume divided by the height. Wonderful. Okay, now, what did they say? Describes the relationship between the base, the volume, and the height. Find the volume. In other words, find V. Solve for V. I want V equals. Because they're giving you the base equals 2 and the pyramid is 6 feet high. They're giving you that the base is equal to 2. The height is equal to 6. And so from that, you can calculate the V. So let's plug in those values that we know. 2 equals square root 3V over 6. Oh, come on, edit undo. Edit undo 6. Okay. Plug in what you know. Just plug in those values. Okay. I got a square root, so what are you going to do? Square both sides. And that gives me, I'm going to go in this direction. That gives me 4 equals 3V over 6. And now you can do this problem, not a problem, because you've done this. Here, you take the point of view of V. V is being divided by 6, right? The opposite of dividing by 6 is multiplying. So you always do the opposite. Multiply both sides to get 24 equals, the 6's cancel, 3V. And so once you got that, V is equal to 8 because you're going to divide by 3. Let's go for it. 8. V is 8. 8, 8, 8, 8, 8. Check your answer. Yay, good job. All right. That wasn't much. It looks like a lot of words. Just accept this. Accept these formulas as being fact. Here's another formula. Let's throw that in there. Let's throw that on a separate piece of paper here. File, new. Okay. Let's throw this guy. If you ever take physics, this is like one of these standard formulas that you're going to see if you take physics. If you never take physics, then who cares? Who cares? T equals 2 pi square root of m over k. This is called the Hooke's law. I'll give you a little background. I don't know. I haven't been to the museum since I was a kid. I probably should go there. They definitely changed it by then. They used to have like a little pendulum. When you enter the museum, there was like a little pendulum that measured that told you the time of day. I don't know if they still have that. But basically, this formula tells you, based on the weight of the pendulum and how stiff the spring is, how long how long it takes for that spring to go up and down or to move sideways. T is supposed to be a time. This is the weight of the spring, and this is how stiff the spring is. That's called Hooke's law, but who cares? Let's see. Basically, it says, well, they got to give you some values here. There's 3 unknowns here. This is like the other formula. time, mass, and spring constant. Pi is not an unknown. That's a value that you can plug into your calculator. If K is 10, okay, let's put down what we know. K equals 10. And what mass, in other words, M, I've got to find M, produces a period, T is the period, equals 2. Okay, so let's plug those values in, see what we get. 2 is T, equals 2. Leave it as pi. Leave it as pi. Square root of M I don't know, divided by 10. K is 10. Okay. So let's take a look at this. We got this times this. We got everything. We got 3 things that are multiplied. You know what I can do? To isolate, well, actually, I can do this. Whoa, let's do this. Okay, to get rid of that square root, why don't we do this? Like I showed you before. Why can't we just square everything? Square everything. Because 2 squared is 4. Pi squared is pi squared. I'm just going to write that. Times M, and when you square the square root, you get M over 10. See, we got rid of this. It's okay to, when you have if you got a bunch of multiplications in the problem, you can, and when you want to square it, you can just square everything involved. This is what you get. But don't forget to square this guy too. We square both sides. Equals 4. Okay. So what I'm going to do next is, see, this is basically, let's see, M divided by 10. Forget divided by, I don't want to divide by 10. What I want to do is multiply by 10 both sides. Because this gives me 40. Equals, see, this is just one big fraction. The top is 4 pi squared M divided by 10. I divide by 10. And so what you're left with is 4 pi squared M. Now, what they're saying is give an exact answer in terms of pi. In other words, just if your answer has a pi in it, just leave it there. Okay? Because if I go ahead and like plug it in, see, they give us a pi to plug in. So you don't need to get the calculator involved. I'm solving for M. M is being multiplied by this mess. I'm going to divide by that mess. Because that cancels this, that cancels this. This gives me M equals 40 over 4 pi squared. And will that be the correct answer? I'm afraid it won't be the correct answer. We're very close to it. See, I see a 40 up top and a 4 on the bottom. 4 goes into 40 10 times. 4 goes into itself once. The correct answer, simplified, is 10 over pi squared. 10 over pi squared. So let's see if that what it looks like. It should be something. Fraction, we got a 10. On the bottom, I got a pi that I'm going to square. Drum roll, check answer, boom, boom, boom. Nice work, yay, 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 yay. What do you think, head spinning?
Yes.
And it's just not, there's not that many word problems. Basically, you accept the formula, plug in what they give you as for variables. They're going to give you one variable that remains. And so you're just going to try to do the math like we did with the other problems. You to get rid of the squared. It looks gross. Okay, and then this pi doesn't help matters either. But pi is a number. I mean, if that was a number 3, you would square 3. When you square 3, you get 18. But when you square pi, it doesn't come out to be a whole number. So what happens is you've got to use the simple pi in order to do this. And just do the opposite operations. Now this guy here is a pain. All right, let's see if we can do it. Luckily, it only occurs once in this homework. Don't save it. Don't save it. Last thing. Oh, come on, go away. File. New. New. Okay, last thing. Hang in there. Okay, they gave us. Now, I don't know if this is a valid equation. The guy could have made it up. But, you know, basically, to find out how old a tree is, you have to cut the tree down, poor bastard. Because you know how you had, the tree has to be, you know, has rings in it.
Mm-hmm.
And the more rings, the older the tree is. But anyway, let's accept it as an equation that says T equals this equation. A over pi minus B and over G. Now let's see what this means here. G is the width of each growth ring. Okay, so you measure the distance. That's a G. This is a G. So if you measure the distance between the rings, the bark width, how much bark it is, and if you can measure the area, you can determine how old the tree is. All right, so complete parts A and B. What about and A? So they want us to solve for A. The age of a tree is given by this. Okay, and A is that. So they want us to solve for A right there. Solve for A. So let's do it. They don't give us any. They don't give us any numbers. So all right, we can't plug in numbers, but we can do a little bit of math. You see this bundle over here? That's a bundle. Okay, that bundle is being divided by G. The opposite of dividing by G is multiplying both sides by G. So I get GT equals, now if I divide by G, the G's would cancel, leaves me with the bundle. So it's looking a little bit nicer. Not much, but it's looking like a little bit nicer, B. Okay, our quest is to get an A by itself. That's what you do when you solve for A or a variable. You want that variable by itself. That plus, see, and you see it's underneath the square root, so you know you need to isolate the square root. That minus B has got to go. And to make it go, you add B to both sides. Just add B to both sides. That's what I'm going to do here. GT plus B, okay, equals, the B's would cancel, square root of A over pi. And now I'm going to square both sides. Square that. Square this. Boom. I get A over pi equals GT. Don't FOIL this out because I'm looking at the answers here and they don't have any complicated answers. They have just, I'm looking at B as a possible answer. So just say GT plus B squared. And we're almost done.
Mr. Silvestri.
Yes, sir.
You have the answers right in front of you?
No, I can tell by looking at it.
Oh, okay.
Okay.
I thought you were cheating.
Oh, I don't cheat. I don't have to cheat in math. I cheat in other ways. But not in math. I was given the gift. Okay. That got me through grammar school. My parents came off the boat from Italy. I was born here, but when I spoke Italian. That's all I spoke. I lived in the south end of Springfield. All the Italians lived there. And what got me through grammar school was I could do fractions. I couldn't speak a little bit of English. Okay, so I used to cry. I didn't know what kids were saying to me. But eventually I picked up English. I forgot the Italian. Never used it. Thank God for fractions, because who knows where I'd be. Okay, I wouldn't be a teacher. I'd be something else. Maybe I'd be on the road holding up a sign. But that's what I thank God for fractions. It got me through grammar school. Anyway, we're not done yet. See, what you're going to do is you're going to multiply this by pi because A is being divided by pi. The pi's cancel. Whatever you do on one side, you do on the other. I'm going to multiply this by pi. This entire expression, multiply by pi, and it looks like A equals this guy. Boom, 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 boom. And you think you're done. Check your answer. I hate when they do this. Okay, you think you're done, then you want to go home. And they sneak a problem up on you. They sneak this on you. Okay? They sneak this. So using this model, equation, a fancy word for the equation, find the cross-sectional area. So in other words, let's come over here. Let me make it nice and pretty. I'm going to copy this. A equals pi times G T plus B. And I'm going to square that. Okay, that's the model. What they want us to do is find the cross-sectional area. So A equals, pi is a number that's on my calculator. Perfectly okay. G is 2/3. Is it 2/3? No, that's the bark width. The growth ring is G. The G is growth ring. 1/3 times T, what's 14-year-old tree, times T is 14, plus B, which is 1/3. B is the, where the hell is B? I can't find. Bark width is 2/3. B, 2/3. Square it. Round to the nearest inch. Okay. Here's where you use your calculator. Here's where you use your calculator. Okay. A equals, I'll leave it as, leave the pi where it is because I have that on my calculator. All right. So what I'm going to do is I'm going to take 14 divided by 3. Take 14 divided by, where's my calculator? 14, where's my calculator? Do I have it? I can't. Let's just easy. 14 divided by 3. 14 divided by 3 equals, this part here is 4.667. You don't have to go crazy with the digits. Plus 2/3 is 0.667. 2/3 is that squared. Okay. And then what I'm going to do is add, before you square, you got to do what's inside the bundle here. So A is equal to, let's just add up those numbers. Pi, I have it on my calculator, 4.667 plus 0.667 equals 5.33. That's all the digits you need. Let's throw another one in there. Squared. Okay. You got to square first. So squaring is an operation you do before you do multiplication. So you have to square first. So I'm going to multiply this on my calculator. I'm going to square that. Square it. I get 28 pi times 28.448. That's enough digits. And last is I'm going to take that number that's on my calculator, multiply by my pi. Where's my pi? Right there. I got a pi button here. Equals, and this is the answer I get. And I really hope this is right because I don't want to do this again. Okay, there's my answer. They say round to the nearest inch. Don't put that in there. Nearest inch. They don't want any decimals. 89.3. 3 is a small number. I'm going to round it to 89. 89, 89, 89. Hit enter. Thank God. Okay, thank God it works. Oh boy, it took an hour. Geez, I thought it'd be shorter than that. All right, I think you got enough to do. Okay, you got enough. Okay, so here's the deal. Over the weekend, I'm going to zero out the stuff that people haven't done. So you did 8-1. We did all the homeworks, 8-1, 8-2, quiz 8A. We did 8-3 and 8-4, and then there's a quiz 8B. You got to do those quizzes, 8A and 8B, and do that over the weekend.
Okay.
Okay, we'll see you next
Okay.
week.
All right. Bye.
Bye.
Have a good weekend.
Hey, Mr. Silvestri,
Yes, sir.
what street in the South End did you grow up on?
I was. Do you remember Mercolino's Bakery on Columbus Avenue?
I do.
Yeah, that's my father used to work there as a baker. But the house I lived in a house next to that bakery that's now a parking lot. They knocked the house down. It was great. The house was $40 a month rent, no heat.
That's crazy.
There was no heat, and we had a big stove, big stove that we all had to huddle around. All the stuff, all the stories you heard about being poor, well, that was it. We did that, but it's $40 a month. The owner of the bakery was Mercury's bakery was Nick Bonacani. You know Nick Bonacani? The father was named Nick Bonacani. He had 3 sons. One of them was a football player, the actual football player. He died recently. He's done. He was done. He had probably, he died. You get old, you die. But that was it. That's the story. Right on Columbus Avenue.
Nick Bonacani was married to my aunt.
Is that right?
Yes. I can't think of her name.
Patsy?
Yes.
That's it. She lived to be like 99. I think she didn't make 100. She did not quite make or did she? No, she did not make 100. 99 or something like that.
I don't quite remember, but my family is from Acushnet half.
Acushnet. Yeah, I remember Acushnet.
Giacchetti family.
Yeah, there was a, let's see, Acushnet. My grandfather lived on Rutledge Avenue. Which right on there's the house. So when you go into Rutledge Avenue, and you know how the Emerson White Park?
Yes.
White Park, the very first house that abutted the park. Okay, my grandfather lived there, owned the house there. It was great. It was back then. It was good. They had a swimming pool in the summer. We would go down there and go in the swimming pool. He grew grapes. We ate grapes. It was fun when I was a kid. He made his own wine. Italians made wine.
Nice.
Okay, I remember he took me to get the grapes because the grapes came from California. We would go to the train station, the same train station we got now without all the fanciness. We would grab the grapes off the train, and we would go down. We go down to a cellar, and he had a big press, and we pressed grapes. We pressed grapes.
Nice.
It was a great time.
Yes, I bet.
It's too bad things change. You know what changed it? Is these freaking computers. The worst thing. Worst thing in the world is computers. A cell phone, that's all right. I mean, the idea behind a cell phone would be good. I mean, if you're, for an emergency, but you don't need a computer in your hand, But that's what ruined the world. But that's all right.
But where would we be right now if we didn't have computers?
We'd be happier. Believe me. And I teach these things. We definitely would be happier. People weren't miserable back then. They accepted life as it is. This internet destroyed things. Okay, we'll talk about it later. You're gonna get me on a rant.
Okay.
All right, we'll see you on Tuesday.
All right, bye.
I'm back.
Bye.